So we have our two tasks. So first of all, lymphoma segmentation. Here we give the AI model a whole body CT scan, and the model learns to output a segmentation of all the lymphomas. And then we had the classification or prediction task. Here the model gets a sliced cube of CT, and the model should predict whether this lymphoma here on the sliced tube comes back within the next 5 years or not. So now in this video, we want to go a little deeper into those AI models. So we already know that this is a model with a lot of variables that are learned through the training. But how do those models exactly look like? Yeah, that's what we want to do in this video here. So, and yeah, we start with an image. Yeah, so in such an image has a lot of pixels. So this is a pixel, this is a pixel, this is a pixel. Of course, it has a lot more pixels in reality, but to keep it simple, we say those are like the pixels here of this image. Well, each pixel has a value. That's like a grayscale value, like a 3, a 5 here. So that's all the grayscale values of the pixels. Yeah. So, and now we already know that we have two kinds of models. We have the convolutional neural networks and vision transformers. So, and let's start with the convolutional neural networks. Yeah. So, convolutional neural networks has a kernel. So, the kernel consists of variables. So, this is a variable, this is a variable, this is a variable, and this is a variable. Yeah. So, in the beginning, you just randomly give some numbers here to the variables. So for example, we randomly give a 2, a 6, a 1, and a 3. Yeah, so this is our starting kernel here. And so this kernel can have different sizes. So here it's a 2 times 2 kernel, but it can also be 3 times 3 or 4 times 4. Yeah. So okay, so now we have this image here again. So and what we now do is we take this kernel and put it here on top of the image. So we start in the left corner and put this kernel here on top of that image. And now we do the following calculations. We always multiply the values that are on top of each other. So we multiply 2 with 3 because they are on top of each other. Yeah. So and then we add 6 multiplied by 5. Then we add 1 multiplied by 4, and we add 3 multiplied by 1. Yeah. So and this gives us 43. So this is like our new value we get out here. So and now we open a new image. So now we take this value here and put it here into the left corner. So this is our 43. So this is our new grayscale value of our new image here in the left corner. Okay. So now we take the same kernel and we go one step over. So now we are here, like at the next step, the kernel lays here, the next, and again we do the same multiplication, right? So and this gives us a 32, and we put the 32 here. So this is our next grayscale value, and then we go over here, the next step, we do the same multiplication, put that value here. So then we go down, put the kernel here, do the same calculation, get this value here, 29, and put it here. So in this, we do this, going continue like this, and in the end, here the whole image is filled with new grayscale values. Yeah, and of course, as you see, it's a smaller image now. Yeah, so this is basically all you need to understand for convolutional neural networks, because this, what I just told you, is just repeated a lot of times. So let's, for example, say we start with an image of 36 times 36 pixels. And then we have this kernel here. This is like, for example, a 4 times 4 kernel. Yeah. So now we start in the upper left corner and we go one step after another, do this multiplication, that stuff. And then we get our new values here, and this gives our new image, which is a little smaller than. So in here we have now 4 of those kernels, 4 different kernels with 4 different variables. Yeah. So we repeat this 4 times, and this gives us 1, 2, 3, and 4 images, new images. Yeah. So and then this is like the first slice, the first part here, and then we have a new kernel here, and we repeat this and repeat this and repeat this, and until in the end we have a vector of numbers. Yeah. So this is how a convolutional neural network looks like. okay? And those variables here, they will be all updated during the training. So in the end, when you compare the output of the model with the real thing, which should be the ground truth, then you go back and the algorithm goes back and updates all the variables here in those kernels, okay? Yeah, those are the convolutional neural networks. Now we go over to the vision transformers. So for the vision transformers, we cut the image in several parts. So here, for example, we cut the image in 4 parts, but it can be also normally, like, we have more pixels, so will be more parts, but it can be also different sizes. The parts, it's 2 times 2, can also be 3 times 3, 4 times 4. So right here, let's say we have those 4 parts. Yeah, and then we write them down here again. So this here is this part, this here is this part, okay, so on. So now we take the values in here and write them down in a vector. So it was here 3, 5, 4, 1, and now we have here 3, 5, 4, 1 under each another. So we do this here for all the images. Okay, so now let's start with this vector here, and now we do a so-called fully connected layer. So, and that works the following way. So we start with, we multiply the 8, the number 8 here, with a variable which we call w11. So this is just again a variable, so the beginning some random number, and we multiply 8 with w11. Then we multiply 2 with a new variable, 2 with w12. So again, new variable, and we add this, and then we do the same here, 1 times w13, another variable, and 5, and we multiply with another variable, and we add all those multiplications. So this gives us a new value up here. And now we repeat this with the 2 here. So with basically now with the next step here. So we take the 8, multiply it with a new variable. We take the 2, multiply it with a new variable. The 1, multiply it with a new variable, and 5 and multiply with a new variable. And here, this is what we get, a new number. So, and we do this here, like we go on like this. Yeah, and then we also add a so-called positional embedding. So the positional embedding is there that the model remembers where this cutout thing was in the original image. And that's a little complicated. So those are like some sinus and cosine functions. We don't need to go into detail here. So, but in the end, yeah, this here gives us some new vector, and we call this vector x, okay? So, and we do this now for all 4 parts here. So we get x1, x2, x3, and x4. So, and those vectors are called our embeddings, okay? So, and those are like just like vectors in the room, you can imagine, yeah? Okay, so now we have those 4 vectors here. And now here we have a matrix of new variables. Again, variables w11, w11, so on. So that's all like all different variables. Okay. So and now this is a matrix called, we call it WQ. And now we make vector matrix multiplication. So we multiply the matrix WQ with a vector x1, and this gives us q1. And then we do the same, WQ times x2, and gives us q2, and so on. Yeah. Okay. So, and those new those Qs here, they are called queries. So now we do the same again. We have again a new matrix of variables, all different variables in here, and we call it WK, okay? And now we again do WK times x1 gives us k1, WK times x2 gives us k2, and so on. And those k's here, they are called keys, okay? So now we need a little more space. So now we build an attention matrix. So we take those Qs, the queries, and write them up here. And we take those Ks, the keys, and write them down here. And now comes the attention mechanism of transformers. So now we look, how high is the attention between the patches? So how high is the tension between this part here, which is called one patch, with this part here, or how high is the tension with this part here, with this part here. Yeah? So how high is the tension from those cutout patches? Yeah. So and therefore we multiply Q1 with K1 and here Q2 with K2 and so on. Yeah. And this gives us the attention matrix. So and then we normalize those here. Okay, and now we take another matrix. Okay, another matrix with a lot of variables, and we call them WV. So and now we do the same again. You already know it. WV times x1 is v1, WV times x2 is v2, and so on. And those gives us those v things that are called values. Okay. So now we again multiply these values in here. So in first first row we multiply v1 everywhere. Here we multiply v2. Here we multiply v3, and here we multiply v4. And now we sum this all. Up. So we take the sum here. We take this, and this gives us delta x1. And now we take the sum here, delta x2, sum here, and so on. So we have those delta x vectors. So now what we can do is, you remember we started with the original embedding vector, which we got out of these numbers here with some variables and the positional embedding. And now to this here, to this x1, we add delta x1, so which we got also from a lot of variable multiplications. Yeah. And we do the same here, x2 plus delta x2, and so on. Okay. So, and yeah, this is the thing which happens in a transformer. Yeah. And this happens a lot, one after another. So it's basically a lot of multiplications and stuff with matrix with some variables. Okay. Yeah. So this is the vision transformer. So now we have the convolutional network, and we have the vision transformer. So now we go back to our example. We had here the segmentation task where the model should output again an image where all the lymphomas are segmented, so we have drawings in here. And here we had a classification or prediction task where the model should get out a number. So and for both tasks, we take the images and pass them either through a convolutional neural network or through a vision transformer. Yeah. So here in there, they are multiplied with a lot of different variables that can be changed during training. So, and now here for the upper part, in the end, we need again an image. So, and here the models always look like a U shape. So first we have like here a convolutional transformer layers, and then we have some upconv layers to get to the original size again, that outputs some image. Well, down here, we add a fully connected layer normally. So a layer which we saw before in a transformer model. So here are like this is like the vector which we get out of a convolutional network transformer here with some numbers. So, and now we take the value which is in this vector here, and we multiply it with a variable, and then we take this number here, multiply it with a variable, take this number here, multiply it with a variable, take this number here, multiply it with a variable, and we add this all up, and this gives us a new value here. So, and we do this then again with different variables, and this gives us a new vector, and so on here until we have only a number left. Yeah, so this is how those AI models look from inside, basically. And there's one thing left, and those are activation functions. So when there is somewhere in the model, for example, the value 4, and then comes an activation function which looks like this, then we go up at the function here and look which value has this function. And here, in this case, it's 0.9. Okay. So when a 4 comes in the model, then we look at the function, and then the value which the model continues with is 0.9. So instead of 4, it continues now with 0.9. So when here was a 4, and then there comes such an activation function, there will be after that a 0.9. And there are several different activation functions, and they are you can find them in several spots inside the model. Yeah, and those functions basically bring the non-linearity to those models. Yeah. So this was now how those AI models here look like, how they work. But as I said before, actually it's not so important to know all the details. It's enough to remember that it's a lot of variables that are changed during training, because in the end you will just take some finished models from PyTorch, from Hugging Face, from Monai or something, or take those large GPT models and fine-tune them. So it's not so important to know that in detail, but now you have a little information how they work and what is happening in there. Yeah, I hope that was understandable, and then thank you very much for your attention.